Welcome to our IEEE Future Networks Initiative Podcast for the Experts series. My name is Alex Wiglinski, co-chair of the Community Development Working Group for IEEE Future Networks Initiative and professor of Electrical and Computer Engineering at Worcester Polytechnic Institute in Worcester, Massachusetts, USA. In this two-part podcast, we will be talking with world-renowned experts on the topic of 6 GHz spectrum and the future of 5G connectivity. April 23rd, 2020 was a big day in the United States for wireless spectrum. On this day, the FCC voted unanimously to open up 1200 megahertz of 6 GHz spectrum for unlicensed use. This newly unlicensed spectrum is a game changer for the wireless sector, especially 6 GHz communications and networks. And there exists both new opportunities and new challenges to utilize this 6 GHz band. In part one of this two-part podcast, we will focus on the changing spectrum landscape. With us today are the Chief Technology Officer for the US FCC, Dr. Monisha Ghosh, and Principal Program Manager for Radio Spectrum Policy at Microsoft, Mr. Scott Blue. Welcome to our podcast.
Thanks, good to be here.
Thanks. Thanks, Alex.
So there's a series of questions that I would love to ask both of you. So I'll start off with Monisha. The question is, how will unlicensed 6 GHz wireless spectrum impact the future of 5G in terms of technological innovation? And what are industry actions that might affect that?
Thanks, Alex. So the unlicensed 6 gigahertz is unprecedented in that 1.2 gigahertz of spectrum has been made available for unlicensed use. In parallel, we also have the efforts of licensing spectrum for 5G cellular. And these two developments go hand in hand. What we've seen in the recent past is that as consumers get used to the level of performance they expect from either their Wi-Fi, they expect that from cellular, and vice versa. So with the unlicensed 6 gigahertz band being made available to not only Wi-Fi, but any unlicensed services, including cellular, what we hope to see is much higher throughputs, latencies, much denser deployments, being able to support a large number of users with higher performance for everybody. And industry is already has been taking note of this action. In fact, a large part of this action was driven by the need of Wi-Fi for higher bandwidths. So just to set the stage here, today most Wi-Fi in 5 gigahertz operates at up to 80 megahertz channels because there really isn't a wider channel availability in that band. And so a big part of opening up 6 gigahertz was to make available more bandwidth. So what having a wider channel does for you is two things. Of course, the throughput goes up, but it also reduces latency. And the Wi-Fi industry, 802.11 in particular, has already standardized 802.11ax or Wi-Fi 6, which will be using 160 megahertz channels. There is also standardization underway for Wi-Fi 7, which will be using 320 megahertz of channels. And having this 1.2 gigahertz of bandwidth available for these new services is going to help these future systems enormously in terms of, as I mentioned, both throughput and latency. We also expect to see unlicensed cellular coexist with Wi-Fi in this band, just like it does in 5 gigahertz. And there may be other new applications that come up. We already have applications like Bluetooth and Zigbee in unlicensed bands in other parts of the spectrum. And we hope that there will be more innovative uses of the spectrum going forward.
Thank you, Monisha. Scott, do you have anything to add?
I guess the one thing I'd add is that we're talking about having 9.6 gigabit a second capable channels, and I don't think anybody's really wrapped their head around what you can do when you're moving that much data around in areas like robotics and industrial automation and those kind of things. I think that's you know for all we've been pushing against trying to alleviate the congestion that we're seeing in Wi-Fi. I think on the other side of this, we're going to see, lots and lots of things that we've never thought were possible.
Thank you, Scott. So my next question, with this additional wireless spectrum available for use with 5G technologies, are there wireless broadband applications that would benefit?
There's an ecosystem that's likely to develop around broadband access in particular. Part of the problem with fiber to the home is that people's Wi-Fi connections weren't as fast as the fiber that's actually getting to the house or to the office or to the other connections. So there will now be the ability to move all the data that comes to the building, and I think that will spur on a whole bunch of new services as we have both the faster and the lower latency connections to the IoT side of things. And I think that's where we'll start to see. And there's a side benefit to that for 5G, in that the more that we grow out the fixed networks to provide homes with this internet access that's capable through higher speed Wi-Fi, it allows the 5G infrastructure and that same fiber infrastructure to be used for 5G as we grow further into the community. So there really is this symbiotic relationship between pushing out the unlicensed spectrum and also being able to push out the infrastructure for 5G.
Thank you, Scott. Monisha, do you have anything to add?
Yeah, as Scott mentioned, I think the industry is still wrapping their heads around what this huge pipe can do for them. Given the situation that we're all in today, working from home and moved all our activities online, this extra bandwidth will go not only to making our Zoom calls and our experiences with video conferencing better, it will also enable things like telehealth, which really requires a lot of the higher bandwidth, lower latency features that actually today are quite difficult to get. And then on the entertainment side, there are applications like AR, VR, which really require both the throughput and the latency aspects that this band will be able to provide that will benefit enormously from the 6 gigahertz.
Those are really exciting answers. This next question, we'll start with Monisha, and the question is, since the 6 gigahertz band is unlicensed, how will coexistence of 5G cellular and other services play out in this spectrum?
Actually, the 6 gigahertz band has incumbents in it already, which will continue to exist there. And the rules were very carefully crafted to provide protection to the existing incumbents. We also will have definitely cellular systems playing out in this. 5G NRU will coexist with Wi-Fi 6E, just as 11 AC and Wi-Fi are coexisting with LTE LAA in 5 gigahertz. In Chicago in particular, we've been doing a lot of measurements and we see a rapid rollout by the carriers of LAA. So, aggregating up to 320 megahertz channels, which gives them an instantaneous 60 megahertz on top of their licensed bandwidth, which allows them a lot of flexibility. So while the unlicensed bands, it's harder to guarantee quality of service or QoS, it is great for applications like downloading big data files. And so what we're seeing is a very smart use of the spectrum in conjunction, of the unlicensed spectrum in conjunction with the licensed spectrum. So applications that require the high quality of service guarantees like real-time video streaming are over the license spectrum, whereas other applications like data downloads can go over unlicensed. We expect that this will continue in 6 gigahertz. There are certain differences in the way the rules were created, most importantly being that in 6 gigahertz, the maximum power that one is allowed to transmit maxes out at a much wider bandwidth, 320 megahertz. Whereas in the 5 gigahertz rules, you could max out your power in 20 megahertz channels. So what that will create is a situation where each system will have to figure out what bandwidth should they be using to maximize both the power they're transmitting as well as their ability to coexist with the other system. And so a lot of the lessons learned in 5 gigahertz will hopefully inform how these two play out in the 6 gigahertz. There's also been encouraging developments in ETSI brand recently, where there has been discussion about using a common threshold for detection between these two systems, which was not there in 5 gigahertz. So we're very hopeful. There is enough bandwidth. 1.2 gigahertz is a lot of bandwidth, which will make coexistence and sharing easier. And we hope to see innovative new solutions come out where both of these systems can productively use the spectrum.
Very exciting. Thank you, Monisha. So it sounds like there's a lot of work going on in terms of ensuring legacy access and while making space for new applications.
So yeah, and one thing I would point out is the legacy is actually, there is no legacy in 6 gigahertz. So it is an opportunity for a clean slate design. And by sort of changing the rules a little bit, where we've tried to incentivize the use of wider channels, we hope that the Wi-Fi will move away from the use of the narrow 20 megahertz channels and move towards the wider channels. In 5 gigahertz, it built up. We started from 20, and then we built up to 80 and 160. In the 6 gigahertz, we're incentivizing the use of the wider channels from day one by basically saying, by putting a power spectral density cap on the power, which means that the wider channel you use, the more power you get. And we hope that that will spur a better use of the spectrum, both for Wi-Fi itself as well as for coexistence.
Excellent. Thank you. Scott, anything you would add to this question?
I've actually spent most of the week on the ETSI brand calls, because there was no face-to-face meeting, to look at this issue, and we're well along in the 3GPP IEEE coexistence work, and hopefully that the two technologies will be able to over-the-air coexist as though they were one thing, which is certainly not the case that it's been in 5 gigahertz. So it's part of having this green field to operate and set the rules so everybody can play fair from the beginning, and hopefully that's going to happen.
Excellent. Thank you. And this is interesting, because I think this actually segues very nicely into our next question, especially with the discussions with ETSI and such, which is, and maybe Scott, if you could start off with answering this question, which is, given this new unlicensed spectrum allocation in the 6 gigahertz band, do you foresee the EU and other countries performing similar regulatory modifications?
Well, I could talk all day about the EU, so maybe I will talk about some of the other countries first.
Sure.
Just this week, heard that South Korea and Taiwan are going to be adopting rules that are fairly similar to the US, similar enough that you'll be able to build one product and it'll be able to ship to all 3 markets. And there's countries as far flung as Brazil and Canada that are looking very closely at something that I expect will be something similar to what's going on in the US. It's interesting because kind of the notions of using 6 gigahertz for Wi-Fi came out of the EU process for the World Radio Conference in 2015, when they looked at using this band for cellular. And a representative from one of the countries said, well, I could see this being used for indoor for Wi-Fi, but I think there'd be too much interference for satellites if it was used outdoor for cellular. And we've actually took that idea back to the FCC and went, well, what about using this band for Wi-Fi? And that process started way back then, 2016, in Europe, and has been a little bit more conservative and a little slower than what's happened in much of the rest of the world. They're looking at just making the spectrum available to 6425, so there'd be a maximum of 3 channels instead of 7 of these large 360 megahertz channels. And there've been a number of problems with the lower band, because there are urban rail, basically subway system control systems that they say are very sensitive to interference in some cities, and yet in other cities they're working in the 2.4 gigahertz Wi-Fi band. So it's been very difficult to do coexistence studies, and so we might end up only having 2 channels in Europe at this point. And then there's some other issues with mitigating interference to fixed links, and different countries have different rules, so there's different sensitivity to the incumbent services that are in there. So it looks at this point like there might be a fairly elaborate system where you'll have to figure out what country you're in first, and ping a database to see whether you're allowed to operate there or not. And then a couple of countries will actually be geofenced and not using the technology initially. Slowly but surely, we'll sort things out in Europe so that we can have products that ship globally.
Great, awesome. And Monisha, any thoughts on how like other countries and organizations around the world might follow suit?
Right. So FCC drew heavily on both the EU reports that were put out on coexistence in this band, and Ofcom's studies in this band. Mm-hmm. As Scott mentioned, the situations are slightly different in every country. Even in the US, it is different from EU, and even within the US, different areas of the country have different incumbents. And because of that, we had to be, I think we were quite conservative in the indoor power levels that we chose, and the outdoor usage will be governed by an EFC. And actually the process of starting up a multi-stakeholder group that will determine what the parameters of the automatic frequency control database should be has already kicked off just recently. We definitely, in order to spur this spectrum harmonization across the world, even if it is for part of the band, would be very, very helpful. We hope that will happen just by looking at what happened in 5 gigahertz and how that helped that Wi-Fi industry in 5 to take off. But having said that, incumbent protection, we don't talk about it often. It is a very important part of setting up crafting the rules for this band. And as Scott mentioned, every country might have to look at what exactly they want to protect and at what level before they come out with a set of rules. But we'll hopefully have at least a few channels that can be used worldwide with the same set of rules.
Excellent. Thank you so much. Do we expect to see any drawbacks or challenges in having 5G cellular operate in unlicensed 6 gigahertz spectrum?
As I mentioned briefly before, some of the rules have changed compared to 5 gigahertz. So there definitely will be a different coexistence scenario. And as Scott mentioned, some of the coexistence thresholds are being reworked to make coexistence better. But all of these should hopefully make coexistence with cellular and Wi-Fi perform better than we've seen in 5 gigahertz. In 5 gigahertz, coexistence was an after-the-fact thought. Wi-Fi was already fairly entrenched, and then fitting in LTE, LAA variants took a little bit of work. With 6 gigahertz, actually, it is great that both 3GPP and 802.11 have started the conversation and are working together to come up with a set of parameters that will make coexistence better. I don't foresee any specific difficulties. Coexistence here will be different, and I hope it will be better. But I hope not to see some of the issues that we did see with 5 gigahertz coexistence.
Oh, that's wonderful. How about you, Scott? What are your thoughts about drawbacks and/or challenges with respect to 5G operation in this unlicensed 6 gigahertz spectrum?
Well, I think to this point we've looked at 5G NRU and Wi-Fi coexistence kind of on an equal footing. What we haven't looked at yet, and mostly because the coexistence is about low power indoor at this point, is the supplemental downlink for cellular services, so that the energy is only going in one direction. Which is it was a concern in 5 gigahertz. It's still a concern now. What does that do to the QoS for both the Wi-Fi and NRU stations that are trying to do something closer to mission critical communication, at least in the enterprise or in the factory. So that's kind of there's a yet to be seen piece on that one. But most of the catastrophic things in 5 gigahertz that were a potential based on products that the LTE community wanted to sell into the market, were not as good. It didn't sell as well as things that really haven't been a problem. So the other side of the supplemental downlink, one of the carriers said to me, if there's Wi-Fi there, we don't need this spectrum for getting extra capacity to our customers, and that seems to have been, it's all very naturally worked out. People are just looking to get internet. If they're getting it some other way, they don't need to go to the extra expense of setting up a more complicated system that's connected to the cellular network. So, there are a lot of we'll see at this point, but things are moving much more smoothly than they were at 5 gigahertz for sure.
And Alex, if I may add a little bit to that,
absolutely.
One of the changes that we made, at least in the US, was in 5 gigahertz. Unlike the rest of the world, US did not have a listen before talk requirement. What we did in the 6 gigahertz rules is put in a contention-based protocol requirement. It doesn't have to be listen before talk in particular, but it could be. And part of the reason thinking behind doing that was to enable the spectrum to be shared fairer than some applications we saw in 5 gigahertz, where if a system chooses not to use a contention-based protocol, it makes coexistence more difficult. So we hope actually that the rules as set out will enable better coexistence of the two systems.
Great, thank you. Excellent. Is there now an opportunity here where this new allocated unlicensed band will spur on significant innovation in wireless technology? In other words, will this new spectrum be a catalyst for research and development in the 6 gigahertz band? Scott, we'll start with you. What are your thoughts about now that we have this frequency band? Will people come? Will this create new opportunities in terms of wireless technology?
Well, I actually think it's already happening. I was going to say happened, but we're still in the middle of it. And it was the combination of this opportunity of 6 gigahertz coming, and kind of some of the bold statements that were made by the IMT 5G community. And so we had the idea of private cellular came out with these much lower latencies based on how 5G was going to operate. And then the folks in the 802 came and smashed their numbers, right? And I've seen multiple examples of new chipsets that are working 6 gigahertz that are significantly lower latency than some of the 5G chips that are sampling. So that kind of pitching one against the other is benefited both, kind of in the same way that we saw between WiMAX and LTE in the 4G space. This opportunity for who's going to have better gear for 6 gig is really pushing the envelope seeing OFDMA come to Wi-Fi and some of the new technologies, and when we have these wider channels that can have the clients communicate back on a subset of those channels, and all these new kind of neat things. Not sure that they would have been there if there wasn't this field of dreams, as you put it, to have the opportunity to play on.
Awesome. How about you, Manisha? What are your thoughts about the newly allocated spectrum and opportunities for a spur in significant innovation in wireless technology?
I completely agree with what Scott just said. We hope that this band will create. So we already know about Wi-Fi and cellular coexisting. We also hope that this will help new applications come out. Some of them have already been brought to the FCC, and our current rules don't actually completely allow them. One of them is unfettered, very low power access, even outdoors. The current rules that FCC has does not allow that, but we did ask that question in a future notice for proposed rulemaking, and that would enable devices that will be able to stream really, really high amounts of data at very short distances at very low power. So enable things like glasses, portable devices that are capable of extremely high data rates. That is not there yet. We hope that will happen in some way, form, or the other. But even given the current scenario, I think it's really, I hope to see actually applications that move beyond just Wi-Fi and cellular come up in this band. So you already have ultra wideband, which operates in part of this band, which will continue to be a service at very low power. The wider bands that the Wi-Fi that we allow here will allow maybe new locationing services to be developed, leveraging the wider bandwidths and lower powers that are available. And for the rest, I would not prophesy what can or cannot happen, because usually what actually comes out is much more than what people can envision 5 years before they actually hit the road. So we do hope that we will see new applications and new R&D that spurs that.
Great, thank you. So this last question is a little bit open-ended. Is where can people go for more information? Like, obviously this is very exciting. There are a lot of opportunities, research development, like industry deployment. Where can people find out more about what they can, and what are the options, and like opportunities for operating the spectrum? So maybe Manisha, like your any insights on where people can find out more about these opportunities?
Sure. So, I mean, if you just want to know about the rules, if you go to the FCC website and just Google 6 gigahertz rules, you will get the actual document which lays out the rules in details. Other than that, Wi-Fi Alliance, I think, has been very active on their website, as well as there are a lot of, I think there are webinars and white papers talking about Wi-Fi 6 and what it can do. There will be, I think, I'm sure there'll be workshop sessions and conferences coming up, which will start focusing on 6 gigahertz. But right now, it's mainly, I would point folks to Wi-Fi Alliance and the FCC websites.
I can personally say that when I found out about this rulemaking, the people I communicate with in social media and stuff, it exploded about how fantastic news this is in terms of the opportunities for growth in the sector, and also how society can be further connected. But I would like to hear from both of you if your thoughts, like anything that was not covered by these questions regarding the future of, now that we have this unlicensed spectrum, where will this take us in terms of society? So maybe Scott, like anything that wasn't covered, like anything you would like to add?
Just to look at Microsoft and some of our internal the R&D folks, that every time you talk to them, it's like, oh, could I do this? Oh, could I do that? Right. And it really is very early days for the people that will take these chipsets and make use of them, of figuring what are the new and exciting things that they can do. On the very low power that Monisha talked about. Um, that people are focusing on this application to connect your phone to some classes, and that'll be the kind of linchpin application. But it opens up kind of body area IoT, all kinds of interesting applications around that I'm sure there's medical devices and other that will spring out of that. But it is a build it and they will come, right? And it really is, it's the biggest playing field of this kind of unlicensed technology, something that I've been involved in for 25 years. There's nothing like this that's happened in the course of my career.
I just echo what Scott said. This is going to be very exciting. What we are going to see is on the Wi-Fi side, you basically are going to have tri-band access points very soon. There's will be a lot of interesting partitioning about, what goes over 5 gigahertz, what goes over 6 gigahertz. I don't believe that everything that we're doing in 2.4 and 5 will automatically move to 6. There'll be a judicious use of the best spectrum for the best application, which is exactly what we want to happen. We are hoping to see much wider bandwidths being used in 6 gigahertz, really leverage the power that was given to Wi-Fi. And the beauty of the 6 gigahertz really is that unlike, say, millimeter wave or 60 gigahertz, where there's actually a lot more bandwidth, the actual challenges for getting chips out quickly in 6 gigahertz are minimal. The industry knows how to work with this frequency band very well. Front ends, IC technology is well known. So we're really hoping to see very rapid uptake of devices being deployed in the spectrum.
Thank you, Monisha. That's fantastic. Great insight. And both Monisha and Scott, thank you again for your time. It's great to ask about your thoughts and insights about this really exciting news in terms of the wireless spectrum community and what it has in terms of impact for the wireless sector as well in general, for our society and our connected society, where we're heading in terms of all these new applications. Thank you very much again to Dr. Monisha Ghosh and Mr. Scott Blue for their insights on this very important and emerging topic. Thank you all for listening to part 1 of our podcast on the 6 gigahertz spectrum and the future of 5G connectivity. And please stay tuned for part 2.
Discover more about the IEEE Future Networks Initiative and inquire about participating in this effort by visiting our web portal at futurenetworks.ieee.org.